अस्सलाम वालेकुम मैम।
वालेकुम सलाम।
मैम मैंने स्ट्रीम लाइव कर दी।
Okay, I think it'll be great. Let's just wait for a few seconds, like for a few minutes or so. For it to show. Let me just set my screen.
So again, really. Yeah, this is something really.
All right. So yesterday we completed the design for YouTube. Today we will discuss how we can design a Google Drive. We know that there are a lot of applications that are helpful for uploading the files and sharing the files with other users as well. So Google Drive is one of them, Dropbox, Microsoft OneDrive, Apple like iCloud, etc. So what these actually also do, like these also sync the files on your local computer to these drives as well. So let's look at an example of Google Drive. Like looks like this. Like we have like a user has its every user has their own drive, and then onto that drive they can upload files and like any kind of files, PNGs. They can also upload videos, folders, or text files, or all those kind of things. So and there is also the functionality. Yes, Abdul Rahman.
Ma'am, I share some chat. You can read it and kindly reply.
Yeah, sure.
So this is actually.
I don't see the message in the chat. Take me to- Right. Yeah, sure. Okay. All right. So, yes, this is how our Google Drive looks like.
I'm curious.
Okay. So, like we also have the ability to search for the files in the Google Drive. Like we can search for the folders or the files, and so like this is like how a Google Drive looks like. We can upload the files, you can download the files, you can share the files with other users. So first thing in every system design interview is to understand the problem and establish the design scope. So we will have these questions with the interviewer, like we can ask like what are the most important features. So for now we can have like download files, features, files, sync, and notifications. And like we want to know if this will be a mobile app or web app or both. We want to have the functionality for both mobile application and web application. Some supported file formats, like we want to support all any file type. Do we need the files to be encrypted? Definitely, we want the files to be encrypted to keep them secure. And file size limit, we want it to be like maximum file size of 10 GB. Like we do not want users to upload a file that is larger than 10 GB of size. How many daily active users we want? Like we want for now 10 million daily active users. So the thing is that we want to have these features in our system. Like we want to have the feature to add the files. Maybe the easiest way is to like you can either have that upload button where you can click upload and then you can browse the files from your computer, or you can also you can also add the files like using the drag and drop functionality into Google Drive. You can we want to have the functionality to download the files, to sync files across multiple devices, because one user can be using the same drive on multiple devices, like on different computers or mobile devices. So we want to make sure that if the user is making any changes on one of its devices, then those changes are being synced to other devices as well. We also want to see the file revisions, file revisions in a sense, like if you have changed a file, you want to see like what was the previous revision. You can view the previous revision. So if you have made any changes or edits to the file, you should be able to see those previous revisions as well. Next thing is like we want to share the files with friends, family, and coworkers. And yeah, so like if there's anything like you want to share it with anyone, like you should be able to share the files, like if you're on the like if you're on the Google Drive or on the Google Docs, like we have the option to share it with the people. We can add the emails, or we can also copy a shareable link, and then we can share that with the with specific persons. And we just also can set the privileges, like if the user can view the file or can make edits to the files and all those kind of things. Last thing is that we want to send notification when a file is being edited, deleted, or shared with you, so that the person who it is shared with is notified that this specific file is being updated or shared. So whenever you share a file on Google Doc and you share it with someone via email, then they get a notification through email that this file is being shared with them. So this is something we also want. And we do not want to discuss the features about Google Doc editing and collaboration, because this is something maybe we can discuss in a different I'm not sure if that is here, but this is something that can discuss in a different, a system design interview, like how to design a collaborative platform for editing the documents. Because that is, so for now, we will not be discuss this in the Google Drive. Google Drive, Google Drive design. So other than these requirements, these were some of the functional requirements that we want for our system. We also want to have some non-functional requirements. So first thing is the reliability. This is extremely important. Why? Because we do not want any data loss in our system, because this system is specifically there to store the files on the cloud. And users do not want any of the data that they have uploaded to be lost, because otherwise if there is no use, they could probably use their own local storage for that purpose. So usually people use these cloud storage because they think that these are reliable to store their data for a long time. So we want reliability, which is the most important non-functional requirement for our system. Next thing is the fast sync speed. So like if when we are uploading a file, and if it takes a lot of time to sync, then this will have a bad user experience, and users might think that this application is not a good or product is not good, then they can abandon the product. So we want to make sure that the system has fast sync speed. Also, we want to have we want to make sure that our bandwidth usage is like as low as possible. So for example, if the product will take a lot of network bandwidth usage, again, users will be unhappy. So we want to make sure that if the bandwidth usage is acceptable on both browser, like both desktop and mobile devices as well. Next thing is the scalability. Definitely because this is a Google Drive, we are talking about the Google Drive Dropbox, and there are a lot of users that are actually using these products, and every single day, a lot of users are uploading the files, making changes to the files, and all those kind of things. So definitely we want our system to be scalable and also highly available, so that users should be able to use the system when some servers are even offline. So we want to make sure that our system is fault tolerant, highly available, scalable, reliable, and fast. So next thing is once we are done with the functional requirements and non-functional requirements, next thing we want to is to do the back of the envelope estimation to understand that how many requests per second we will have, and how much how much storage we will be needing. So for this, let's assume that the application has 50 million signed up users and 10 million daily active users. So so what happens is users we are saying that we have 50 million signed up users on the system, and out of 50 million, 10 million are using this product every day. So we get 10 GB of free space, users get 10 GB of free space, and they can later maybe upgrade the storage if they want. But this is something that they get for free. And users can upload, let's assume that users can upload users upload 2 files per day. Although this might not be true. Maybe some users are uploading 10 files or more than that, but for now, let's assume on average users upload 2 files per day, and average file size, assume it's 500 kilobytes. So we want to have 1-to-1 read to write ratio. Then it means that total storage that we will be needing is because we have 50 million signed up users, right? And each user is getting 10 GB of free space, which means total space we will need for our system is 500 petabytes. And then queries per second for uploading the files is we have 10 million active users who are using the product daily. And we are assuming that each user on average is having 2 uploads per day. Then we divide it by 24 hours, 3600 seconds to compute the queries per second. So this will be 240 queries per second. And to make sure that we are able to handle the load at peak times, so we just say that peak query per second, we just assume that it might be double, so we just make it to 480. Now that we are done with the back of the envelope estimation, you know that we need a lot of storage, and our system should be able to handle at least this many queries per second. So first we will design. The next step usually in all of the system design interviews is to go with the high level design first, and then we dive deep into some of the components of that high level design. So first thing is the so here we will first before directly jumping into the distributed system, we will first start with a single server setup, because with this single server setup, it will be easy for us to discuss what are the major components, how the flow will look like, and then we can further we can definitely make it distributed later using load balancers or sharding or applications and those kind of things. So let's assume that we have in this single server setup, we have a web server that will upload and download the files. We have a database that will keep track of the metadata. We can have the user data, we can have the login information, we have files information, file size, all those kind of things. And we have a storage system where we will want to store the files. So for now, we assume that we have 1 terabyte of total storage on our storage server. Later we'll see how we can increase this storage once it is once we are out of storage. So for now, for all of the users, we are assuming that we have 1 terabyte of storage, and since we are assuming a single server setup, so for this, what we might be doing is since we want to want to have this system, we can say, okay, we can have an Apache web server where we can implement the functionality to upload and download the files for users. We can have a MySQL database, and then we can simply have a directory on our storage server called Drive, where we can store the uploaded files. And then inside the directory, we can have the list of directories, because this is something that is for multiple users, because multiple users can upload the files on this drive, right? So for this purpose, we are going to have like separate folders inside this root folder. We like have separate folders for each user. So we said this is for user one, this folder is for user one, user two, user three. And then is the user one inside those users directory, each user can have, whenever a user is uploading a file, their file will be uploaded in their respective directory. So an example of this looks like this, like user one has these files, user two has these files, and so on. And we also assume that the files names do not change. So these remain the same as the users have uploaded with the exact file names. And maybe we can also later on add functionality for file name change, but for now we assume that it's going to be the same. Next thing is like what do the APIs? So next thing is like we have already discussed, like this in this single server setup, we will have an Apache web server, a MySQL database, and a like drive or directory where we can store the files. We can assume that this directory might be on our actual server. Like for simplicity, for now we can assume that as this is the Apache web server where we have all of the code hosted for uploading and downloading the files. And maybe on the same server we can have a drive like we have on our system. There is a D drive, C drive, etc. So we can have a specific drive where we can store those files, right? File storage system. We're assuming that currently we have a file storage system. So this is the simplest setup or design that we can think of when we are designing a like Google Drive storage system. So next thing we talk about is the APIs. So APIs are like first thing we want to do is like we want to have the functionality to upload the files to the Google Drive. So we are assuming that we have two types of uploads that are supported, either a simple upload or a resumable upload. A simple upload will be for files that are of small size, so we can upload those small sized files in just one chunk. And for resumable upload files, we can upload like this type of upload will be used when the file size is really big, for example, 10 GB. In that case, we want to have some parallelization. Probably we want to have this file, we want to split this file into multiple chunks and then upload these files in parallel. So we want to have these two types of upload types. And so now that we know that we want to have two types of upload, so we can have this API, right? So we can have this API. You guys might already aware of the RESTful APIs. Like we have this we have the resource location and then the specific resource that we are trying to access. So this is the API for upload. So this will be the endpoint for upload. And then we want to have this query parameter where we have like we want to set the upload type to either the simple or resumable. If it's simple, then we know that it's for small size, and the file will be uploaded in one go. And if it is set to resumable, then the file will be splitted into multiple chunks and then uploaded. Parameters for this will be like the upload type. This is just we can make this a query parameter in our actual URL. And then the data can be the post, this can be a post operation because we are uploading something. So this is going to be a post operation. And for this, we can have like this payload where the data will be the actual contents of the file. So this is something that we can have. And so a resumable upload will be achieved by following these three steps. Like we will send the initial request. First of all, whenever we have to upload something, we are getting some, like we talked about this yesterday on in the YouTube section that how we can make our uploads secure. So we can maybe get a pre-signed URL from the system. We will talk about for this later, like when we are storing the files on S3 storage. So whenever you are uploading files on S3 storage, there is a term called pre-signed URL that is for making your uploads secure, to make sure that your users, like the file that is being uploaded is authorized and uploaded by an authenticated user. So what do we do? The initial send the initial request to retrieve the resumable URL, and then we upload the data to our storage, and then we monitor the upload state. We can maybe continuously monitor. We can do some polling to check if the user, maybe we can check after 5 seconds if the upload has been successful or not. And once it is done, then we know that we are done, that file has been successfully uploaded. So in case if the upload is disturbed, then we can resume the upload as well. Okay. Next API is the download file, because we want to have the functionality to be able to download the files from the Google Drive. So so for this one, we have this endpoint download, and parameters for this will be just a path, where we just provide the URL for download file path. An example of this could be like, this is inside the recipes folder, soup folder, and this is the file name that we want to download. So this is just the API, what's for download will look like. The next thing is the next API we want to have is to get the file revisions. Like we discussed, if something is changed, if someone has made updates to the file, then we want to see that if we have any previous revisions of this file, we want to check how many revisions have been made to the file. So for that purpose, we can have this API called list revisions. This is the endpoint for getting the file revisions. So this parameters for this could be the path of the file you want to get the revision history, and we probably also want to have the limit, like we want to have the maximum number of revisions, because it is possible that the number of revisions are really big, maybe 100, 200. Then in that case, you probably want to get only the latest 20 revisions of the file. So this is how your example parameters might look like the path and the limit of the in the payload. Okay, next thing is like, we know that since these are RESTful APIs, and definitely whenever we are implementing the APIs, we want user authentication always to keep the APIs secure. So we want all APIs to have user authentication, and we want to use the HTTPS over HTTP. And so this HTTPS will make sure that these SSL will protect the data transfer between the client and the backend servers. Next thing is like, we are done with, like, we have already discussed like how we can have a single server setup. Now the thing is that since we are building a scalable system, definitely single server setup will not be helpful for us. First of all, it will not be scalable. It is fault tolerant. There is single point of failure issue and a lot of issues that we can have with single server setup. So what we can do with this, maybe we can use the single server setup if we are building something for our company or small company where employees can upload their files, and we know that there are not a lot of daily active users, and we do not need more than 2 terabytes of storage. So maybe we can, in that case, for a very small setup, we can have this single server setup. But for something that is being used globally by a lot of users, then we want to build something that is scalable and distributed. So to look at this, we want to move away from single server. Yeah. So what we want to do is like there will be a point when the storage will be full, because right now we are assuming that we have only 1 terabyte of storage. So maybe after 2-3 days, some users are uploading the files, and then it gets filled, and we have only 10 megabytes of storage free available. So when this point happens, then users will not be able to upload new files to the servers, to the drive. So what we want to do is, first thing we want to do is to perform the database, to perform this sharding on the storage servers. So what we can do is, probably we can say, okay, let's just have multiple shards. Like maybe we can use, we can say that let's just have a 1 shard per user. So it means that one user will have 1 storage, other user will have, like, each user will have their own storage server and those kind of things. So we can perform the sharding to have separate storage servers per user. So when you're about to perform the database sharding, then you can just perform this, and then you are good. You know that now you do not have the, you do not need to worry about out of storage space here. So even if the out of storage space happens for some user, for example, this was user two used all of its storage space of 1 GB. I think that 10 GB, this was the total free storage that we had available. So we say that 10 GB storage per user, 10 GB for user one, 10 GB for user two, and so on. So if a user utilizes all of the free storage, then they can maybe upgrade, and if they upgrade, then we can have the horizontal scaling to add more storage for that specific user. And so we do not need to now worry about the storage out of storage issue. Next thing is the so what can we use for this storage? Because we are done with this storage. We are not worried about the storage issue now. But the next thing is we want is the reliability. We want to make sure that because we want to know that we do not want to lose any of the data that we are uploading to these servers. So for this purpose, we can say, okay, maybe we can use Amazon S3 for storage, because the Amazon S3 is storage that is used for, it's an object service storage that actually offers you the scalability, data availability, security, and performance. So you do not need to, if you use Amazon S3 storage, then you do not need to worry about these scalability things, reliability, availability, and all these kinds. And these are all built in the Amazon S3. So we can use Amazon S3 for storage. Previously, we were saying that we have a local server, like a drive on our local on the server, Apache Web Server, or separate server, where we can have like the separate where we can have the storage maybe where we had this 1 terabyte of storage on the server. But that is not definitely a reliable place to store the data. So that's why we use Amazon S3 to make sure that our storage is reliable and highly scalable. So now that you are done with the S3 storage, there is one thing about the S3 storage is that you have the ability to, there is a term called bucket. So bucket is just a unique identifier for each S3 storage. So what happens on the Amazon S3? Like if there is a bucket that is already named with something, maybe let's just call it user bucket one, something US bucket one, something like this. So if someone has created a bucket with this name, then if another user in the globe tries to create a bucket with the same name, then it will not be able to, the user will not be able to create it, because the thing is that S3 has this one limitation, that the bucket names must be unique. Although I think this has now been like recently, I think S3 has changed. Like Amazon has, maybe I think AWS. I just read an article about this. I think Amazon has made some change about this. Now they do not need to worry about this unique name. But this used to be true for before 2026. So so what happens, like you have this bucket, and inside the bucket, so what you can do is like to make sure that your data is not like, to avoid the loss of the data, to have the reliability, what you can do is you can do the replication. So you can say, if I have stored the data in one bucket, then I can replicate it into multiple buckets, so that if for any reason this bucket has the data loss, I at least have the copies of the data on some other buckets available, and I can get the data from those buckets. So we can perform replication to improve the to have high reliability, and we can also do this in multiple regions. We can have the same region replication and cross-region application as well. Region is something like a location of the data center. So AWS has like multiple regions. It has regions in US, like US East, US West, and like in other countries as well. So you can say that I can maybe to improve the reliability. What I can do is I can replicate the data in same region and multiple cross region as well, like in different region, from region A to region B as well. So why we need to do this replication is like to have the high chance of reliability. Let's suppose due to some earthquake or due to any natural disaster, something happens and data centers gets down, like this happened recently in, I think, Dubai, like, I'm not sure where it happened, like one of the data center was due to war, like Iran had like, I think sent some missile on the data center and it got destroyed. I'm not sure exactly, but this is something that I read. So these natural disasters can definitely happen. So we cannot rely on single region for our data. We cannot rely on single regions to store our data. So that's why we want to make sure that our data is replicated across multiple regions. So if anything happens, if due to any natural disaster, or for any other reason, the data center goes down, at least we have the data available in other regions. Yes, Ifan.
मैम अजोर के अंदर जब हम ब्लॉग बनाते हैं तो उस वक्त तो हम जस्ट हमने सेलेक्ट करना होता है कि ये ब्लॉग मल्टी रीजन हो या ना हो। क्या AWS के अंदर भी ये फीचर है कि हम खुद चूज कर सके कि कौन कौन से रीजन में हमारे डाटा पड़ा हो और कौन कौन से रीजन में डाटा ना पड़ा हो, जब हम मल्टी रीजन क्रॉस रीजन की बात करते हैं? क्या वो हमारे हाथ में
Definitely
होता
you can do that. This is something that is in your hand. Do you want to have a replication enabled in just one region, or you want to have replication enabled in multiple regions? This is something that you can do in the configurations.
है? यानी कि हम खुद कॉन्फ़िगरेशन चेंज कर सकते हैं कि ये
Yes, yes.
US ईस्ट में हो या US
Yeah.
वेस्ट में। ओके
Yes,
ओके।
exactly. Okay, the next thing is like is this so now that you have put the files in your S3, now you do not need to worry about the data losses. You have performed replication on multiple regions, so you are good to go with this requirement as well. Next thing we want to have is the scalability. So we want to make sure that our system is able to handle millions of users, millions of daily active users without, and it's highly available, it is scalable. So first thing that we usually do to make our system scalable and distributed, we just introduce this load balancer. So what this load balancer does, it just distributes the network traffic among multiple servers. So what we do is like, instead of having single server, first of all, we put the load balancer between web servers and our client application. So now we have this load balancer. Now using this load balancer, we can spawn multiple servers based on the traffic. So if the traffic goes high, this load balancer will automatically spawn more web servers, like more Apache web servers, where we can send the traffic to if one of the server is already like it has its capacity reached, then we can spawn another server and send more new requests to that server. So this will make sure that our system is scalable and highly available. Next thing is like, so we are done with this, and we also this is how our distributed high level design will look like. We have the users, then they send the request to the load balancer, and then we have web servers where we have the functionality for downloading, uploading, and all those kind of things. And then we have this metadata DB where we are storing the metadata for the files that we are uploading. And here we are storing the files. Then we have the S3 file storage where we are storing the actual files. Definitely in a distributed system, we also want these to be scalable as well. So these will also be distributed. We do not have just single file storage. We have multiple file storage, cross-region applications, sharding, and all those kind of things that are being there. On metadata DB, we have sharding, we have multiple servers, we have master slaves, and all those kind of things here. Maybe we also have leader election. We just do not need to talk about those in detail, but these are the things that we have to make sure that our systems are highly available and scalable and fault tolerant. So next thing is the sync conflicts. How we can handle the sync conflicts. So the thing is then when multiple users, so what can happen is like, let's suppose there is a file that is shared among multiple users. Let's just say it's a file named F1. So and it is being shared by 2 users, right? So what happens, like, what if user 1 and user 2 both are trying to update this file or edit this file together at the same time? So in that case, sync conflicts can happen. How we can handle these sync conflicts? So so what happens is like, let's suppose so what we do in this case, like if the if a system is able to system is able to process the update from user one first, then that update will be kept. User one will be notified that his update is successful. But the other user that was trying to update the file at the same time will get a notification that there is a conflict in his updates. So looking at this example, so let's look at this. The user one is trying to update. Both are trying to update at the same time, right? But due to network bandwidth or due to any latency, maybe this user had low latency, this user had high latency. So this user wasn't able to get the system wasn't able to process his request. System was able to process the user one request first. So the user who gets whose request is processed first will be notified for the change, and the user who wasn't able to do the second user who was trying to update will get a conflict error or warning or like those kind of things. So when this happens, then what user 2 can do, like system gives the user the ability to be able to choose, like if they want to keep the, like they have this version 1 and this is the version 2. So they give the user the ability to either merge both of the files, or maybe keep just one version. Maybe they want to discard this version and they want to keep their own version, this new version. So this is just the functionality that we provide the user whenever a conflict happens. So like now we are done with this thing. Now let's look at the overall high level design of our system. So so what happens, like we have this user, like where we have the browser, the way it might have using browser or mobile device. So we have this load balancer that will distribute the traffic among multiple servers, and it will perform horizontal scaling if new servers need to be added or removed. And then we have these back block servers. So these block servers will be used for uploading the files in chunks. We will just discuss what these block servers are there, and then we have this cloud storage. This is the S3 storage where we store our files. And this is the cold storage. So cold storage is used for the files that are not being accessed for a long time. So if something is because sometimes what happens is that users upload, or most of the times what happens is that user upload the files on the cloud storage for backup. So what happens is that they probably do not need to access those files for maybe a year or 2 years. So what we do is those files that are not being accessed for a long time, we can just put those in the cold storage, or we can say that this is just the archive. So we can just put this in cold storage, and this is also, there is also an like the option in S3 to put your files in the archived storage. So you do not need to set up this on your own, but you can do this with configuration in your S3. So those files will be put in the cold storage, and then the files that are being accessed frequently will be present in the S3 storage. Next thing is like we have this metadata cache. Metadata DB, we also already discussed what are these. Metadata DB is just for keeping the file information, like what is the file size, file name, and all those kind of things. And metadata cache is for accessing the file information. Like this is, we introduce the caches usually when we do not want to send multiple requests, same requests on DB multiple times. The requests that were being accessed previously, those can be cached in the metadata cache to like avoid performance bottlenecks on the DBs, and for fast retrieval of the queries from the cache. Next thing is the notification service. So this notification service we will be needing is like whenever a user uploads a file, updates a file, or delete a file, we want to send the notification to the user that their file has been updated or has changed or has been deleted, and those kind of things. So for that purpose, we will need the notification service. We already discussed the design of notification service in previous sessions, like how we can build a distributed notification service system. And then we have the offline backup queue. So why we need this backup queue is like if for some reason, like because if user was uploading a file, or even when you are on the Google Doc, you are making some changes on the document and you go offline, you are still able to make some edits in the file, but you are not able to retrieve the latest changes from the, like if someone else is updating, like in the shared collaboration, let's suppose if someone is updating the file with you and you get offline, then you will not be able to see the changes made by the other user. So what happens in that case is like if a user gets offline, then the changes will be stored in the offline backup queue. So when the user gets offline, those changes will be synced to the user's devices when the user gets online. So this is how overall high level design looks. Let's look at the block servers because this is something that we need to discuss in. So block servers usually normally are just the these will upload the blocks to the cloud storage. So blocks are just the chunks of the files. So what happens is like whenever you are uploading a file, this file is being splitted into multiple blocks. It is being splitted into multiple blocks, and then each block is individually stored to the cloud storage, and then we can have a then we can have some algorithm to assemble these blocks into single file once these are being uploaded. Because we can actually store the order number of the files whenever we are splitting the file. So when we are like assembling these together, we will know that in which order we have to assemble these back to bring it to the to recover the original file. So let's look at it. Let's go to the design deep dive. First thing we need to discuss is the block server because this is the first important component that we would like to discuss further. So what happens is like the large files that are being updated regularly. So what you want to do is like first of all, like, first time you have, for example, a 10 GB file you want to, or maybe let's just suppose you want to upload a 5 GB file. So what happens in this case, you are not actually, you do not want to upload this file at once, like in just one, as a one chunk. What you would like to do to increase the speed of upload, you would like to split this file into multiple blocks. So what this block block server does, it splits your file into multiple blocks, and then each of the block can be uploaded independently of the other block. So once this block is being uploaded, then it is compressed. We compress it for we compress the file so that the size of the file is being reduced and it is easier to upload. So we just do some compression, and once the file is being compressed, we also encrypt it to keep it secure, and then we store it to the cloud storage. Then each of the block is first compressed and then encrypted and then loaded to the cloud storage. So this is how your first time upload works. But if the users next challenge is like, what if the user update the file? Like they make some changes to the file and then they try to upload again. So in that case, what happens, like we do not want, like if because large files might be updated frequently. So what we don't want to do is like every time user make a change, we do not want to upload the whole file again. So what we can do is like with this block server setup, what we can do is like we can just simply, when a user make a changes, so we can just upload the block that is being changed. We do not need to worry about any unmodified blocks. So this will make sure that we are only, whenever a file is being updated, we are only uploading the changed modified blocks. So this will also speed up our process and will avoid any repetitive work. And yeah, so this is what our block server will be doing. One example of this is, let's suppose you had these 10 blocks of a file that was being split into 10 blocks, and then on the next upload, user just made changes to block 2 and block 5. So once these are being changed, only the changed blocks will be uploaded again on the next time to the server. You do not need to upload these again. Okay,
मैम मतलब ये कि जो हम फाइल अपलोड करते हैं तो वो ब्लॉक्स में कन्वर्ट हो जाती है।
हाँ, वो बैकएंड पे आपका जो ब्लॉक सर्वर होता है, इट कन्वर्ट लाइक इट स्प्लिट्स इट इनटू मल्टीपल चंक्स, स्मॉल चंक्स में। अगर 5 GB की लेट्स सपोज फाइल होगी तो इट माइट बी स्प्लिटिंग इनटू 4 MB चंक, 4 MB चंक्स में हो सकता है वो इसको डिवाइड करते हैं।
फिर उसके बाद जिस तरह डेल्टा लॉग्स राइट होते हैं, उस तरह फिर इसके डेल्टा लॉग्स राइट होंगे अगर कोई चेंजेस करता है। जिस फाइल
Yeah.
में
Yes.
ओके
All right. So this is what we had for the block server storage. Next thing is like we want to have high consistency requirement. Why we do want this is because we want to have strong consistency in our system. Because the thing is that if you are having a collaborative thing where you are updating the things, like multiple users are updating something at the same time, then definitely when users want to read a file, they do not want to read. So for example, if user one is like if, for example, this was we had this file, right? And this user updated the file, right? User one updated the file, and before that, user two and user three were reading the file.
Yeah.
So what happens is like if we do not have the strong consistency, then it is possible that user two is reading an old version, user two is reading the latest version of the file, but user three is because the thing is that the system is distributed, right? System is distributed and we have replicas, and the thing is being like these are being updated. So there, if we do not have the strong consistency in our system, then what can happen is like the changes have not been reflected to the user three storage yet. So what could happen is that like user two is able to read the latest version, but user three is still seeing the old version. We do not want this kind of consistency. We want this is something called eventual consistency, where you eventually like eventually after some time overall data is consistent for all users, but we do not want eventual consistency. We actually discussed this. You can probably go through with this in some previous sessions. We discussed what is strong consistency, what is eventual consistency. So we do not need to discuss this here again. So the thing is that we want strong consistency in our system. So the thing is like when something is being updated, all of the users are able to see the similar exact same changes in the system. So for this purpose, like we have like the relational databases are very suitable for strong consistency requirements because of their ACID properties. But the thing is, NoSQL databases do not support ACID properties. So we are saying that we want to use, in our design, we choose the relational database because of these strong consistency requirements. The next thing is the metadata database. So because metadata database is storing the information about users files, like we are not storing the actual files in the metadata database. We are storing those files in the S3 storage, but we also need to store these information in somewhere. So for that purpose, we use the metadata DB, and this is how our schema would look like. So our schema would have a user table, block table, device table, workspace table, file version table. User table will have the information about the users, like user ID, username, when this user was created, and then each user can have their own workspace, like each or their own folder in the drive. So and we also have this, if this workspace is being shared with other users or not, and all those kind of things. And then we have like inside the workspace, like there are files for each user. So we have a file table, we have all of the information about file. And we also want to store the file versions when the files are modified to get the revision history. So for that, we have this file revision table. And we have this block table for storing the information about the blocks for the files, like because we discussed this, that block server will split the files into multiple blocks. So for that, we have this block table, and then we have this device table as well, because one user can have multiple devices and we want to sync the changes from whenever a change is being made on one device, we want to sync the changes on multiple devices, all of the logged in devices. So we have this device table for that purpose. So this is how our metadata DB schema would look like. Next thing is we want to talk about the upload flow, like how the upload flow would look like whenever a user is uploading a file, what will happen back behind the scenes. So So we have, let's suppose, a client one who tries to add the file metadata, like it tries to perform two operations. First, it tries to add the file metadata, and then it tries to upload the file. So when the user adds the file metadata, then we will definitely there will be behind the scenes there will be load balancers, but we are talking about the sequence diagram, that like how exactly the sequence would look like. So client will trigger this will trigger an API on the API servers. Then the API servers will upload the file, like upload the data on the metadata database, and then we will set the upload status to pending, because it is not the file is not yet uploaded. Right now we have only uploaded the file metadata. And then once this metadata is being uploaded on the metadata DB, then we will notify the change to the notification service. And now this notification service will send the notification to a client 2 that the file has been that a metadata has been uploaded, like a new file is being uploaded on the drive. So next thing is like the user tries to upload the file. So this will definitely first go to the block server, because when user is uploading the file, this will need to be split it into multiple blocks. So block server will split the file into multiple blocks, and then this will upload those blocks to the cloud storage. Once all of the blocks have been uploaded, it will also update the file metadata in the metadata DB, like update the rows of the block in the block table. And once all of the blocks have been uploaded successfully, then the upload status will be set to uploaded, and then this will notify the change to the notification service. And finally, notification service will send the notification to the respective client that the file has been uploaded successfully. If for any reason file upload fails, or maybe user tries to upload a file that is more than 10 GB, then probably we can also send that kind of notification that the file upload has failed, or like file format is not good, of those kind of things. So this is how our overall upload flow would look like. Next thing is next thing is the download flow. So we also need to have the functionality to be able to download the files from the drive. So what happens in the download flow is that what happens here is so we know that when file is being uploaded, a notification was sent to a client that the file has been uploaded. So this client will now need to download the file, download the changes, download the file to have the latest changes. Also here we are not talking about we are not here talking about the actual users, like they will not be actually downloading the file, because whenever something is updated. So let's suppose there was a shared storage where user one made the changes to the file. So what happens is when these changes are being made to the file, then these file needs to be those changes need to be reflected to other users directories as well, so that they can see the latest changes. So this is we are talking about the client in that perspective. So this is that client that is trying to, whenever something is uploaded on the server, then this client will download those changes and update the respective storage for those shared users. So how will this flow look like? So this change is being notified to this client. Now this client will get the changes from by sending an API to the API servers. API servers will get the changes from the metadata DB. Metadata DB will return the changes to the API servers. Now API servers will send those changes back to the client. So now client has know that which blocks it needs to download, because we already discussed that we do not need to download every single block that is being updated. So we do only need to, this will return the blocks that are being updated. And then these blocks can be downloaded using the block servers. Block servers will download the blocks from the cloud storage. Cloud storage will return the blocks back to the block servers. And then these block servers will send the blocks back to the client, and these updated blocks will now be stored on the storage of that specific user, and then that specific user will be able to see their latest changes. I think we should just end the discussion for now, because we are out of time. Any questions? Yes.
मैम क्वेश्चन था मेरा, लेकिन वो इससे रिलेटेड नहीं था ना। तो वो क्वेश्चन ये था कि AWS में और GCP में ऐसा मतलब क्या डिफरेंस है कि हर कोई जो है ना GCP के लिए मतलब रिसोर्सेज ढूंढ रहा होता है, और तीन है ना हमारे पास, एक है AWS, एक है Azure और एक है GCP। अब Azure के तो काफी कम मतलब रिसोर्स चाहिए होते हैं इनको ना, लेकिन उसकी इतनी ज्यादा मतलब डिमांड नहीं दिख रही है। AWS और उसके बाद है GCP क्यों इतना पॉपुलर है? क्या चीज़ है इसके
I think
अंदर जिसकी?
AWS is also very popular. It actually depends on the cost